Hi, I'm Charlie with Precision Matthews, and we've got a technical video for you today. I often get questions about the best way to change the primary drive belt on a variable speed knee mill. And I've changed enough of these belts to come up with a system that works pretty well. This process will apply to any of our variable speed knee mills, and also any Bridgeport pattern knee mill. This job is a hassle no matter what, but it's a little easier if you have some idea of what you're doing. So save yourself a lot of headache, and watch this video before you do your first belt change on your variable speed knee mill. Let's get started. You'll want to do a couple things before you even start. First, turn on the mill and crank the speed all the way to the fastest setting. This will put the front pulley in the easiest position to work with in subsequent steps. Unplug the mill before you do anything else. Then, I think it's worth it to take both side covers off. Taking off those covers is not strictly necessary, but it takes 1 minute, and I like to see what I'm doing. After you've triple checked that your mill is unplugged, you can open up your motor's pecker head and disconnect those wires, since we'll be taking the motor off entirely. Don't forget to take a photo of where the wires go before you start. You'll thank yourself later. By the way, is there a better word for this electrical box than pecker head? I've literally only ever heard it called this, and I'm too scared to Google that on my work computer. Put it in the comments if you know a more polite name for this part of the motor. Now that we're ready to dive into the mechanical bits, we'll start by taking the bottom bearing plate off at the back. And while we're removing screws, we'll get the ones up top that secure the motor to the top of the casting. Now this cover is a little challenging to get off since it's a tight seam, but I've found that a putty knife and hammer is the right tool to get started. And the comment section loves when I misuse tools, so feel free to yell at me because I'm using a putty knife and there is absolutely no putty anywhere in sight. Now that I have a gap, I'll just get my pry bar and... Wait, what's this? This warning label can't stop me because I can't read. Then your pry bar of choice once you get a little bit of clearance. Once you get the bottom cover off, you can see why it was so tight, as the bearing on the end of the motor shaft is seated in this plate and keeps it tight to the upper casting even when you take the screws out. Next order of business is to get this bearing off so that we can compress the spring that's behind it. The problem is that it's slightly recessed, and most of the wedge-style bearing separators won't clear the casting. It's possible to get the motor off with the bearing in place and without compressing the spring, but you'd better have a healthy budget for the swear jar, because doing it that way makes it even harder than it already is. My solution is a semi-custom puller, which is just the smallest puller in the 3-piece set that they sell at Harbor Freight, plus some modifications to the jaws with the bandsaw and bench grinder. The top jaw in this photo is an example of how it comes out of the box, and the bottom shows how I alter all 3 jaws. This way, the tip of the jaw pushes on the inner race of the bearing, and you don't damage the bearing when removing it. And here's how the puller looks when it's in place. Once you're done with it, you can throw it in your drawer for the next time you need to change your belt. Here, I'm squeezing the puller jaws together with my left hand and turning with my right. This makes for a bad camera shot, but it keeps the jaws on the inner race of the bearing. It's not the end of the world if one of the jaws slips and pulls on the outer race a bit, but we're still trying to do our best here. The whole reason we're taking the bearing off is so that we can thread in some long M6 screws and compress this spring. The designers of the assembly were nice enough to give us bored holes on the bottom seat of the spring and tapped holes on the top. If you join me at my workbench of anachronism and skip to where the motor is already off the machine, you can see how tightening either of these screws compresses the spring and spreads the cones apart. This gives slack on the belt that you're going to be thankful for in a second when we take the motor off. There are 2 screws for even force and so that you don't get hit with spring force if something happens to one of the screws. I have a healthy respect for the ability of heavy springs to injure me, so I'll take a second M6 screw every time. With the spring now fully compressed and the pulley cones in their widest position, get a friend and pull the motor off the top, tilting it back as you go to take the belt off. We weighed the motor at 66 pounds, which doesn't sound like a lot until you're trying to hold it at head level with one hand and wrestle the belt off with the other. So get a helper and make one person primarily responsible for the motor and the other person responsible for the belt, while also helping with the weight of the motor if needed. Now we'll move to the front of the mill and remove the 3 screws from the top bearing plate, since that needs to come off as well. Like the bottom plate on the back of the head, this plate also houses a bearing and needs to be pried off. Because you removed the screws, it will spin freely with the spindle, so here you can just pry, spin it a third of a turn, pry again, and repeat until you get that plate free. Usually with this one, the bearing will come free with the plate, but if it doesn't, you can pull it using the same method as before. Taking that plate off will reveal these 2 screws, which you'll take out to free the speed control plate. This plate is what modulates how far apart the cones are, changing the spindle speed. We're finally ready to go around and take out the 6 bolts from the bottom that hold the main drive housing on. Then the whole casting just lifts off. Once we get it off, we'll get it upside down on the bench and I can show you how the speed control hand wheel moves that speed control plate. From this view, you can intuit why you need to follow this warning advising you not to turn the hand wheel when the mill is powered off. If you move to a faster speed while the mill is off, the cones will be further apart and the belt will get slammed into place when the motor starts moving. If you move to a slower speed, this will pinch the belt. That's because the cones move closer together and the belt can't climb the cone when it's not in motion. Both conditions result in premature belt wear. If you accidentally move this knob while the mill is off, you can often correct your mistake by turning the spindle a few rotations by hand to gently move the belt to its new position at its new speed setting. Now the part we've been waiting for. I take off the old belt, walk off camera, and come back with that very same belt, because this is actually a brand new machine that didn't need its belt changed at all. And of course, assembly is the reverse of disassembly. Head cover goes on. Don't forget to put the speed control back to its highest speed if you were like me and you played around with it on the bench. This was the easiest position to get the machine apart, and it's still the easiest position when the machine goes back together. Now install the 2 screws that secure the speed control plate to the top cone. And with that secure, we'll install this top bearing cap. We make sure that all the mating surfaces are clean, then we rest the bearing in the top cap, flip it into place, and lightly tap it home with a mallet. We're not going crazy with force here, it shouldn't take much persuasion. Once it's seated, the 3 screws are installed, and we're good up front on top. With the top bearing plate snugged down, now you can install those 6 screws to secure the main drive housing. Okay, it's starting to look like a mill again. With the spring on the motor shaft still compressed by those 2 screws we installed earlier, grab your friend and put the motor on. We'll just start the 4 motor mounting screws finger tight. We're not cranking them down until we get the bottom bearing plate installed, and this motor is quite secure just as it sits, but if an earthquake hits, I don't want to be wondering if my milling machine motor is going to fall on my head. Now we'll tend to the bottom end, and that starts with removing the screws that are compressing the spring on the motor shaft. To save time, make sure you do this in fast forward, like I'm doing here. Slow time back down to clean the bearing surfaces and tap your bearing on the end of the shaft. You don't have to get it all the way on, just get it started. Because next, we're putting the bearing plate in place and tapping that on. You can tap that most of the way, then the 3 screws draw it up the rest of the way and seat that bearing fully into the cap. A very important but easily overlooked step: after the bottom bearing plate is secure, don't forget to then tighten the motor mount screws down. I've certainly never forgotten to do that. Don't let them put in the newspaper that I forgot to do that. Then just wire the motor back up, referencing the picture that you took earlier. Thanks, Past Charlie, for taking that clear picture of where the wires came from. Last but not least, if you took the side covers off for access and visibility like I did, you can now kiss the belt goodnight and put the covers back on. So there you have it. Changing the belt on a variable speed knee mill is no one's favorite job, but with the best practices that we've covered here, you can at least go into the job confident that you're not going to mess anything up. There are a lot of people changing these belts a lot of different ways, so if you've found any tweak or shortcut that we didn't mention, let us know in the comments. As always, thanks for watching.